I'm Wim Tielemans. I'm a professor of chemical engineering at KU Leuven, and I'm located on the Kortrijk campus. Our research focuses chemical depolymerization of condensation polymers. So then we think of polyesters, polycarbonate, polyamides, polyurethanes, for example. These are polymers that have chemical linkages which we can selectively break down to bring the polymer back to its original building blocks, the monomers. And they can then be repolymerized, reused in polymers, just like virgin material. And so we can make polymers with the original properties than we had in the beginning. So we don't do any downcycling, we can reuse the materials in exactly the same way as before, or even in higher value products. We focus in this project on recycling of textiles, because in textiles these days we have a lot of combinations of different materials. Think of cotton together with polyesters, cotton together with polyamides, polyurethanes. And so at the moment these mixed textiles are not recyclable because we can't mechanically separate them to then reuse the materials individually. So we need to selectively depolymerize or selectively remove one of the compounds, one of the polymers that we have in there, so that we can retain the rest. So to recycle the mixed textiles, we need to remove one of the compounds at a time. So we can first, for example, in a textile that contains polyamides, polyesters, and cotton, we can first remove the polyester, then remove the polyamide, and then retain the cotton, which then can also be reused. And the way we do that is by selectively attacking the linkages in either the polyester or the polyamide to then depolymerize it, so bring it back to its monomers. Then we can, with solvents, we can remove it and then take the textile that is left over and take it through the further steps for recycling. And so what we will do is, for example, in a mixed textile of cotton, polyester and polyamide, first remove the polyester by chemical depolymerization, then remove the polyamide by chemical depolymerization, and then retain the cotton fibers and then characterize the cotton fibers to make sure that they can still be reused as new cotton fiber. And then the monomers we obtain for the polyesters and the polyamides, we can then reuse to make new polyesters, new polyamides, which can then be reused either again in textiles or in any other application where these polyesters and polyamides might be useful. So why we work together with University of Lille is because there's a very good research group, the research group of Philippe Zinck, with expertise in the polymerization. So what we do is we break down the polymers, we chemically depolymerize them to the monomers, and then in collaboration with the group of Philippe Zinck, we will repolymerize them and make new polymers with them, so that we can close the whole loop from taking a mixed material, and in this case a textile, chemically depolymerize it, remove the polyesters and the polyamides, then repolymerize it to polyesters, polyamides, and check that we can get materials with the original properties.